This is going to be assignment 2, case 3, a plate tilted at 60 degrees into oncoming flow. Here is my student ID. It is hard to see. My PID is 4065587. So to begin, we're just going to go to the XY plane, and also like before, I have everything set up already, so I'm just going to go through it and generally overview it so it doesn't take too long to upload to YouTube. But yes, to begin with the geometry, let's see here. We need to begin with our initial tilted plate. So we start over here, and we're going to actually go to, hold on, is this sketching? Yes, okay. So we're going to go to sketching, we're going to go to line, and we're going to draw a line from the starting point to any point along the x-axis, and we're going to draw another line just at any angle kind of in this direction. To get the exact angle between these two plates, we have to go to dimensions, we have to go to angle, we can click on that, click the angle between this angle and this angle, and you can adjust it down in, where is it? It should be details down here, and you can actually input the angle. So in order to get these dimensions correct, you can go to dimensions, general, and then you can drag out a little line from each of these sides, and it'll help you identify how long it is with here. And you can input the 50 centimeters for the length and the 5 centimeters for the height. Following that, we need to create our system. So we're going to go over here. We're going to go to sketching again. Go to draw rectangle. And you can draw this large rectangle, making sure it's large enough so that the weight can be identified in the back of the flow. After that is done, we can go to concept, surfaces from sketches. We can click our geometry that we want and generate it. And this is why we have this gray surface. And the plate is actually, as you notice, it is not gray. That's because we want flow to go around it. So the next portion we're going to have to do is the meshing. And the meshing, again, is already done, but I'm going to explain very quickly how it's done. This is the mesh, the final mesh that I came up with. To get this mesh, you can go to Insert, Method, and that method is basically going to be an automatic one. So it'll break up your mesh into like a general one, and then you can refine it, which I'll show you to do right now. To make it a little smaller, you can go to element size, go to 0.05, specifically for this model. After that, you can go to refinement. You can get to there through mesh, insert, and refinement. If we click on this, we can go to, it starts on level 1 as default, but we can put it to level 2 and click generate. And that'll give us the mesh we see here, which is, it's very small and will help us get to the correct solution. So the next portion is to do the named selections. So for our system, the inlet where the flow is going to be coming is to the left, and our outlet is to the right. The symmetry is there just because flow isn't going up or down, it's just going in the x direction. Additionally, we also have to name the boundaries to this plate here, the bottom of the plate, top of the plate, back of the plate, and front of the plate. And we have to do that because that'll help us identify our forces acting on the plate in the next section. So following that, we are going to go to our solution. Again, the solution has already been calculated, but I'm going to go through how I got to it. So here we're going to click the viscous model. Slide up here, we're going to use the standard K epsilon model. Enhanced wall treatment and pressure gradient effects will be checked off. Minimize that. For our materials, we are going to be using air, so we don't have to change anything with that. Our boundary conditions, the only thing we need to change is our inlet. We'll edit that to, it was initially set to 0, but we changed it to 10 meters per second, just like the other cases, making sure that's a velocity inlet and the outlet is a pressure outlet. That is it for boundary conditions. We can go to reference values, computing from our inlet. This will change to your 10 meters per second. We can go to initialization, initialize our calculation, and then we can run our calculation, making sure to set our iterations to a high number so that if it takes a while for our answer to converge, that it does converge eventually. Once that calculates, you will be able to have access to the report section and the forces tab. And if we click print, that will display all the forces acting on the plate and different parts of the plate. So we have our back, bottom, front, top of the plate, and the pressure force, viscous force acting at each of those specific locations. Here we have the net force of the viscous and pressure forces. And at the bottom, we have our total pressure force acting on it and the total viscous force acting on it. This will be discussed further in the report. So next we can go to our results tab and start contouring our pressure and velocity. So one second, let me share my screen. Okay, we're gonna go to results, open that up. See how we have green check marks here? That means we're all set. I'm gonna quickly share this screen with you as well. Just like that. All right, so now we have to move this to the XY plane. First, let's make a velocity contour. So we'll go to contour. Just like that. We're gonna go to calculate it from the symmetry 2. Change this to velocity. And we're gonna adjust these contours to 200. And as you can see here, this is our velocity contour. Next, I'm going to do a pressure contour. So I'm going to undo this, insert contour. I'm going to do this pressure. We're going to do symmetry 2 again. Pressure is already set to as the variable. And we're going to change this to 200 contours. And we wait. As you can see here, this looks pretty good. Our stagnation point is going to be getting more significant because we're going to have more of an area that has little to no velocity. And we also see this low pressure area in the wake region. So in order to see where the flow separates, we can actually uncheck this. We'll go to vector, and we're going to do flow separation. Click OK. Our location, again, is going to be symmetry 2. We're going to do velocity with a factor of 1, and we will apply. And when we zoom in on this, we'll be able to see where our flow actually starts to separate. So according to this, our flow begins to separate right where this bluish green color vector ends. So approximately right here. And if we want to get an exact location for that, we can actually go back to our setup and plot the shear stress of the top plate on an XY plane. And wherever the shear stress is 0, that's where our flow will begin to separate, which is at this point right here. And that will conclude the video for assignment 2, case 3. The next video will be assignment 2, case 4 with a 90-degree plate. Thank you.